Hi, it's Alan Begg here from MacMaths, and welcome to today's mathematics lesson. We're going to continue on with the topic of change subject of formula. Previous video I did was an introduction to this topic. For this video, we're going to concentrate on addition. Let's do a little review at the start. What is change subject of formula? Let's consider this formula. Z equals x plus y. In this formula above, z equals x plus y, z is what is called the subject. Z is the subject. In this formula above, z equals x plus y, x and y are called variables. X and y are variables, and z is the subject. The objective of change subject of formula is to change of your formula from one thing to another. In this case, it would be changing it from z to either x or y. At the moment, the subject of our formula is z. Z equals x plus y. Change subject of formula is changing the subject from z to either x or y. At the moment it's z, and we want to change it to either x or y. When we know the values of the variables x and y, we can work out what z is, because z is x plus y. But if we know the values of z and y, what does x equal? The objective of change of subject of formula would be to rearrange the formula to make x the subject. Alternatively, if we know the values of z and x, we can rearrange the formula to make y the subject, so we can work out what y equals. Change subject of formula is moving variables or numbers from one side of the formula to the other side of the formula to make them the subject. Change subject of formula is moving variables or numbers from one side of the formula to the other side of the formula to make them the subject. At the moment, our subject is z, and we want it to either x or y. How do we go about that? Whatever operation the variable or number is doing on one side of the formula, it must do the complete opposite on the other side of the formula if you move it from one side of the formula to the other side of the formula. The opposite operation is called the inverse operation. Whatever operation the variable or number is doing on one side of the formula, it must do the opposite on the other side of the formula. This is called the inverse operation. There are rules to follow when carrying out change subject of formula. There are 4 rules. The 4 rules cover addition, subtraction, multiplication, and division. Rule 1. If you add a variable or number on one side of the formula, you must subtract it on the other side of the formula. The inverse operation of addition would, of course, be subtraction. If you're adding a variable or number on one side of the formula, if you want to shift it to the other side of the formula, you must reverse the operation, do the inverse. So addition on one side, subtraction on the other side. Rule 2 is the same scenario, but for subtraction. If you're subtracting a variable or number on one side of the formula, if you want to move it to the other side of the formula, you must change the operation, do the inverse, and subtraction would become addition. If you multiply by a variable or number on one side of the formula, you must divide by that number or variable on the other side of the formula. So we have subtraction being the inverse of addition, addition being the inverse of subtraction, and now we have division being the inverse of multiplication. And unsurprisingly, Rule 4, of course, deals with division. Division on one side, multiplication on the other. When you change a subject of a formula, the new subject must be written as a positive and never a negative. So what does that mean? Let's explore that. The actual result when you work out the formula might be a negative number. Your answer might be negative. But the sign for your subject must always be positive. It can never be written as a negative. When you have your formula, you can't have a negative sign in front of your subject. You must have a positive sign. Let's consider these 2 formulae. X equals z minus y and minus x equals z minus y. So you can't have negative x. You must always have your subject being a positive. Obviously, we don't actually put the positive sign in front of our subject, but the important thing is it mustn't have a negative. When you've rearranged your formula to change your subject cannot be negative. You can't leave it as a negative. Let's have a wee look at this example here. X equals Z minus Y when Z is 20 and Y equals 5. When we work out this formula, the answer is plus 15. X equals Z minus Y, X equals 20 minus 15, which equals 15. Let's look at this example. B equals C minus A, where C is 10 and A is 15. When you work out this formula, it ends up being a negative number, so that's okay. It's okay for your answer to be negative. You just can't have your subject having a negative number to start with. So here we are, B, positive B, as we said, you don't actually put the plus in, equals 10 minus 15, which is minus 5 in this instance. Minus 5's okay, you just couldn't have minus B. So to summarise, X equals Z minus Y would be okay, that would be an okay format, but minus X equals Z minus Y would not be. Once you've moved in prior subjects to change the subject, you can't stop when you have a minus in front of your subject. You need to continue on with your movement to ultimately get the new subject to be a positive. Let's look at some examples. We're specifically looking at addition of variables or numbers. In this particular lesson, we'll look at subtraction in the next lesson, and multiplication and division in subsequent lessons as well, of course. Here's our standard formula. X plus Y equals Z. And the objective of this example is to change the subject of form to X. At the moment it's Z, we want to change it to X. The way we're going to do about this is remembering rule 1. We're going to abide by rule 1. If you add a variable or number on one side of the formula, you must subtract it on the other side of the formula. X plus Y equals Z is where we're starting from. To change the subject of formula to X, we end up with X equals Z minus Y. What have we done there? We want it on its own on one side of the formula. In this case, we're going to concentrate on having it on the left hand side of the formula. It doesn't matter whether it's ultimately on the left hand side of the formula or the right hand side of the formula, as long as it's isolated on its own. So first thing is, we need to move the Y from one side of the formula to the other side of the formula. To do that, we've changed the sign. We're adding Y on the left hand side of the formula. If we now move it to the right hand side of the formula, we must subtract Y. We've changed from X plus Y equals Z to X equals Z minus Y. That's us changed the subject of formula from Z to X. put some numbers in. X equals z minus y. Z is 5, y is 3. X will equal 2 because x equals z minus y. We know z is 5, we know y is 3. 5 minus 3 equals 2. X equals 2 in this instance. Let's check that that's correct by substitution. Let's check that the formula is balanced. If the formula is balanced, the same answer on both sides, we know we have done it correctly. X plus y equals z was our initial format for the formula. We've worked out that x equals 2. We knew that y equals 3 and equals 5. Let's put those numbers into the original format for the formula and see if z equals 2 is ultimately the correct answer. And it is. On one side of the formula you have x plus y, 2 plus 3, which equals 5, and on the other side of the formula you have 5. 5 on one side, 5 on the other, it's balanced. So x equaling 2 was the correct answer. We've proved it. Let's look at this example. B plus 10 equals C. So now we don't just have variables on one side of the formula, we've also got a number. But remembering back to our rule, we treat numbers and variables the same. If we want to move numbers from one side of the formula to the other side of the formula, we just carry out the inverse operation. The objective here is we're going to change the subject of formula to B. Step 1, we're going to rearrange the formula on the left hand side to put B at the very start. It just makes it tidier because we want to isolate B on its own. So let's have B at the extreme left of the left hand side to start with. Now, we've changed from A plus B plus 10 to B plus A plus 10. So we haven't changed any signs, but was that an okay thing to do? Could we just shift the B and the A around? Could we just turn them around? Is that okay? Is this okay? Let's prove that that's an okay thing to do. Let's consider these numbers. 3 plus 2 plus 10 equals 15 is the same as 2 plus 3 plus 10 equals 15. So you can see that by moving the 2 from the second place to the first place and swapping it with the 3 from the first place to the second place makes absolutely no difference to our formula. So it's okay to shift the 2 from second place to first place in the same way as it's going to be okay to shift the B from second place to first place. So that's okay to do. We've proven using real numbers that that's okay to do. Now, we're going to start moving the stuff we don't know, we don't want, from the left-hand side to the right-hand side to isolate B on its own. First thing we're going to do is we're going to move the a. At the moment, we have b plus a plus 10 equals c. So we've moved the a from left-hand side to the right-hand side. And we've done that by changing the sign. We've changed it from plus a to minus a. We've done the inverse operation. Adding a on one side of the formula means you subtract a from the other side of the formula. We now have b plus 10 equals c minus a. To isolate the a, we need to move the 10. Currently, we're plus 10 on the left-hand side, so that becomes minus 10 on the right-hand side. We've moved the 10 from the left-hand side to the right-hand side. We've changed from adding 10 to the inverse operation, minus 10, subtracting 10. Let's check to see if that's okay by putting in some real numbers. Let's check that the formula is balanced. This is where we've ended up by changing the subjective formula to b. We know that c equals 15 and a equals 2. Whenever you do one of these examples in a test or examination, you'll be given the variables for c and a, what they are, and you'll be asked to work out what b is. And you do that by substituting them into the formula. So b equals c minus a equals 10. b equals 15 minus 2 minus 10. 15 minus 2 is 13, minus 10 equals 3. So we've worked out, given these variables, C15, A2, that b will equal 3. This is where we started. A plus b plus 10 equals c. A equals 2, b equals 3. Is it balanced? 2 plus 3 is 5, plus 10 is 15. So we have 15 on the left-hand side of the formula and 15 on the right-hand side of the formula. This is balanced. So b equaling 3 is the correct answer. What's the actual practical use of change subject of formula? Why are we doing this? Let's have a look at a couple of real-world scenarios that we can use change subject of formula in. Here's the question. The combined ages of Bob and Fred is 30 years. If we know that Bob is 13 years old, how old is Fred? So the combined ages of Bob and Fred is 30 years old. We're given that Bob is 13 years old. But how old is Fred? If we convert that into a formula, x plus y equals z, x being Bob's age, which we're given in the question, 13 years old, we're being asked to work out what age Fred is, what's Fred's age, we'll put the variable y down for Fred's age, and we're given Z being the cumulative age of Bob and Fred, and we're told that that is 30 years old. So what we're going to have to do is change the subject of this formula from Z to Y, because Y is our target. Our objective is to find out how old Fred is. So we need to change the subject of the formula to Y. First step, we're going to reverse X and Y to have Y on the extreme left of the left hand side. Then we're going to move X from the left hand side to the right hand side. We've shifted the X from the left hand side to the right hand side to isolate Y on its own. We had plus Y plus X on the left hand side. Now we must have minus X on the right hand side. Adding on one side, subtracting on the other side. So to change the subject of formula from Z to Y, this is what we end up with. Y equals Z minus X. Let's substitute in the information we know. We know that Bob's age is 13. We know that Z, the cumulative age of Bob and Fred, is 30 years old. What is Fred's age? Let's put these numbers in. Z, the cumulative age, is 30, and we know that X equals 13. Is Bob's age? Y, which is Fred's age, is 17. 30 minus 13 is 17. So Fred is 17 years old. That's the answer to our question. We've used change of subject formula to answer this question. Let's look at another practical example. The combined weight of a bag of pears and a bag of apples is 3 kilograms. We know that a bag of pears is 0.7 kilograms. So how much does a bag of apples weigh? The combined weight of a bag of pears and a bag of apples is 3 kilograms. We know that a bag of pears is 0.7 kilograms. So how much does a bag of apples weigh? We're going to use X plus Y equals Z again, where X is the weight of a bag of pears, 0.7 of a kilogram. Y, the weight of a bag of apples, is our target to find out. And Z is the combined weight of a bag of pears and a bag of apples. And we're told that that is 3 kilograms in total. We're going to change the subject of formula again to Y. First step is we're going to reverse the Y and the X. We do this by moving X from one side of the formula to the other side of the formula. On the left hand side we are adding x, so that means on the right hand side we must subtract x. To change the subject of formula from z to y, we move the x from the left hand side to the right hand side, and we do the inverse operation. The inverse operation, remember rule 1, is changing from adding x to subtracting x. Remember, this is our question. What's the weight of apples? Put the numbers in that we know. We know that Z, the weight of apples and pears, is 3 kilograms. We know that the weight of pears is 0.7 of a kilogram. Therefore, the weight of a bag of apples is 2.3 kilograms. 3.0 minus 0.7 equals 2.3. The answer is that a bag of apples weighs 2.3 kilograms for this specific example. We've done a couple of examples. Let's do some more by way of a quiz. First question, change the subject of formula to x. Currently we have x plus y equals z, so the subject is z. What do we have to do to change it to x? To isolate x on one side of the formula on its own, we have to move y from one side of the formula to the other side of the formula. Rule 1 of change subject of formula means that if we're adding on one side of the formula, we must subtract on the other side of the formula when we move a variable from one side of the formula to the other. Add y on one side, subtract y on the other side. Once more, let's prove that that is correct by using some real numbers. In this instance, let's have x equals 10 and y equals 5. 10 plus 5 equals 15. This is our changed formula, changing the subject from z to x. Let's substitute these numbers in. X equals 15, which we knew what z was, minus y, which we knew was 5. 15 minus 5 equals 10. So x equals 10 is correct. The formula is balanced. It's the same on both sides. 10 on one side, 10 on the other side. Question 2. Change the subject of this formula to x. X plus 2 times y equals z. So to isolate x on its own, we've moved the 2 times y, 2y, from the left hand side to the right hand side. On the left hand side we are adding 2y. If we move it to the right hand side, we must subtract 2y. Let's put some real numbers in again. X plus 2y equals z. if we know that x equals 10 and y equals 5, we have 10, which is x, 2y, which is 2 times 5, which is another 10. 10 plus 10 equals 20. This was our changed subjective formula. Let's put the numbers in and see if it's balanced. X, which we know is 10, the other side of the formula, 20, which we know is z, 2y, 2 times 5, 2 times 5 equaling 10. This side of the formula is 20 minus 10, which is equal 10. So on one side of the formula we have x, which is 10. On the other side of the formula we have 20 minus 10, which is also 10. 10 on one side, 10 on the other side. It's balanced. Question 3. X plus y equals z. Change the formula subject to y. First thing we're going to do is we're going to switch x and y. We've proven in the previous slides that that's an okay thing to do. When you're adding variables, it doesn't matter which order you're adding them in, the answer will always be the same. So we had x plus y equals z. We've switched the x and the y, and now we have y plus x equals z. Then to isolate the y, we've moved x from the left hand side to the right hand side, and by doing that we have done the opposite. Instead of adding x on one side, we're now subtracting x on the other side. We've changed from x plus y equals z to y equals z minus x. Let's put some real numbers in again. X plus y equals z for x equals 10 and y equals 15. 10 plus 5 equals 15. So we now have x equals 10, y equals 5 and z equals 15. Our changed subject formula was y equals z minus x. If z is 15 and x is 10, 15 minus 10 equals 5. So we have 5 on one side of the formula and 5 on the other side of the formula. It's balanced. That is correct. Question 4. Change subjective formula to y when we start with x plus y plus 18 equals z. First thing we're going to do is we're going to switch the x and the y. So we had x plus y plus 18 equals z. Step 1, we've changed it to y plus x plus 18 equals z. We're going to move the x from one side of the formula to the other side. We're going to change from adding x to subtracting x. Step 1. But now we still have adding 18 alongside the y, so we need to move the adding 18. Same rule applies whether it's variables or numbers. Instead of adding 18 on the left hand side, we must subtract 18 on the right hand side. We started with x plus y plus 18 equals z. The objective was to change the subjective formula to y, and now we have y equals z minus x minus 18. Let's put some real numbers in. x plus y plus 18 equals z, for x equals 10 and y equals 2. 10 plus 2 is 12, plus 18 is 30. So we now have x equals 10, y equals 2, and z equals 30. Let's put that into our changed formula when we've changed the subject to y and see if it's balanced. On one side of the formula we have 30 for z, 10 for y, minus 18. 30 minus 10 is 20, minus 18 equals 2. So we have y equals 2 on one side, y 2, and we have 30 minus 10, which is 20, minus a further 18, which equals 2. We have 2 on one side, 2 on the other side. It's balanced, so that is correct. Question 5. 2x plus y minus 7 equals z, and we have to change the subjective formula to y. First thing we're going to do is we're going to switch the 2x and the y. We're going to change it from 2x plus y to y plus 2x, and the rest of the formula remains the same. Then we're going to move the 2x. So we're going to move adding 2x from one side to subtracting 2x on the other side. That leaves us with y subtract 7 equals z subtract 2 times x. If we're subtracting 7 on one side, we must add 7 on the other side. It's the inverse of the subject. We'll be doing more on subtracting variables and numbers in the next lesson, but here's a wee taster of what to do if we've got subtracting a variable or a number and we want to move it from one side or the other. That will be rule 2, the inverse of subtraction being addition. Let's put those numbers in and see if it's balanced. If we're given that x equals 10 and y equals 2, we have 2x, 2 times 10, which is 20, plus y minus 7 equals 15. 20 plus 2, 22, minus 7 equals 15. So we know that x is 10, y is 2, and z equals 15. Let's see if our changed subjective formula to y equals z minus 2x plus 7 works out and is balanced. Y equals 15 minus 2 times x being 2 times 10, which is 20, plus 7. 15 minus 20 is minus 5, minus 5 plus 7 is 2. Balanced on one side, balanced on the other side. So we have correctly changed the subjective formula from z to y by checking that the formula is balanced. How did you get on with those quiz questions? I hope you managed to understand the theory of change of subject of formula when you are adding variables and numbers. Next lesson will be on change subject of formula when we are subtracting variables or numbers. This is Alan Begg from McMaths signing off. If you have any value from this, lesson, please like, share and subscribe. See ya.